Okay, our third example is going to be done using eliminating a variable by addition. And if you remember, the idea was when I have my system of equations, if I add the two equations vertically and I can get rid of one of the variables, then I can solve what's left, and then I can use some back substitution to find the missing piece. So let's go ahead and see what this looks like. So I'm going to have the system of equations that 4x squared plus y squared equals 13, and x squared plus y squared equals 10. Alright, so the idea was, if I have a way to add these things vertically straight down and get rid of one of the variables, then I can use elimination. I can add these things and use elimination. The problem is, if I were to add the 4x squared and the x squared, I get 5x squared. If I were to add the y squared and the y squared, I would get 2y squared. I wouldn't get rid of anything. But remember that you can multiply an entire equation by some value to change its coefficients. You're not going to change the equation as long as you remember to multiply every single piece by that value, because you're going to keep the balance of your equation that way. So the idea is, well, the y squareds look like they're very close. If I could just make one of them negative, it would take care of it. So what I'm going to do is I'm going to take this bottom equation, and it didn't matter really, just the bottom one looked easier to me, and I'm going to multiply it by a -1, because what that's going to do is change the sign of everything, and then when I add the y squareds together, they'll go away, they'll be 0. So now I'm going to rewrite my system. I'm going to rewrite the whole system over here of 4x squared plus y squared equals 13. And now I'm going to rewrite the bottom equation that I've multiplied by -1. So I multiply everything by -1. That gives me a -x squared minus y squared equals -10. And so now I can go ahead and I can add these things down, and I'm going to get rid of my y squareds, which is good. So now I'm going to add the x squared part together. So 4x squared minus 4x squared is going to be 3x squared. Positive y squared, negative y squared added together is 0. That's what we wanted. And then 13 and -10 is going to add up to 3. So now what I can do is I can go ahead and solve this equation. Now, I don't have to get everything to one side here because of the fact that there's no single x term. There's just an x squared. I can use the square root property here, which means I can divide both sides by 3 first. So then I would get x squared equals 1. Then I can take the square root of both sides, but here's the thing, don't forget this part, very important. When I take the square root of both sides here, I have to do the plus or the minus on the right side of this thing, because you're going to get two possible values when you take the square root. And the square root of 1 is just 1. So here what I get is the positive or -1. So that gives me my 2x values. And by the way, we didn't mention it here, but let's go back and look at these. This bottom one here is actually a circle. Both things are squared, and they have the same coefficients. The top one you might think, oh, that's a circle. We really haven't dealt with this. It's actually not a circle. It's what's called an ellipse, which basically is a circle that's kind of been stretched in one direction or another. So it's more oval shaped. But you did not have to know that specifically, but you do have to know that at least it's got basically the same type of principle as a circle. So you could have two circles here overlapping themselves. And circles are kind of interesting in the fact that, or circles and ellipses are kind of interesting in the fact that they could have two solutions. They could have one solution because they just touch each other. They could also technically have 4 solutions, especially with an ellipse. And we'll see if that's the case here. I don't remember if it is. But I'll kind of graph this real quick just to show you what I mean by that. You could have, again, an ellipse is a stretched out circle. Kind of looks like an oval. But now think about this. What if the circle does this? Or maybe it's another ellipse, but in this case it's a circle. Well, now what you can see is that I would actually have 1, 2, 3, 4 solutions. I could have up to 4 solutions on one of these things. And technically you could have an infinite number of solutions if the ellipse and the circle happen to be the same equation. We're really not dealing with that in this case. All right, back to our actual problem. So what we found is we found two x values, which we have to plug back into one of our equations to find the y values. Well, to be honest with you, from everything that we've done here, this equation right here looks like it's the easiest one for us to deal with. So I'm going to plug in x equals 1 back into my equation and see what we get. So we get 1 squared plus y squared equals 10. Well, 1 squared is 1 plus y squared equals 10. If I subtract the 1 on both sides, we get that y squared equals 9. But then I have to take the square root of both sides to solve this. Once again, I'm taking the square root on both sides of the equation, so I have to do plus or minus the 3, because that's the square root of 9. So what that tells me is that x equals 1 is associated with two y values. This sounds like it's actually going to be one of those things where we have 4 solutions. So what that means is I could have x associated, oops, I'm sorry, I didn't actually mean to write the x. X is associated with positive 3, so I could have the point 1 positive 3, or I could have the point 1 negative 3. There are two solutions when x equals 1 on this particular problem. Now we have to do exactly the same idea, but when x is negative 1. And again, I'm going to go back to the same equation, so I'm going to plug the negative 1 in. And if I square negative 1, that's 1. Subtracting 1 on both sides will give us y squared equals 9, which means if I take the square root on both sides, once again I get the plus or the minus of 3. So when x equals negative 1, it is also associated with 2 points. So we are actually going to have 4 solutions. We will have 4 intersection points. So I've got one where x is negative 1 and y is 3. And then I've got one where x is negative 1 and y is negative 3. So it actually does look like the sketch that I made above there. That is what our solution sets are going to look like. So that's 2 of the points. That's 2 of the points. We actually have 4 solutions to this particular equation. Biggest thing, when you take the square root on both sides of the equation, make sure you're using the positive or negative, or you're potentially going to lose a couple of your solutions. All right, our fourth example, once again, we're going to use the addition method. So let's go ahead and set up our system. So we're going to have y equals x squared plus 3. And we're going to have x squared plus y squared equals 9. So, again, let's look at what these are. This top one, this is a parabola. And the bottom one here is a circle. Now, I didn't mention it before. I think I kind of actually left this out. This has the possibility, depending on how skinny this parabola is, I didn't even think about it before, this parabola could be a really skinny parabola, something like that. And the circle could be big enough that when you draw the circle, that's not really a circle, but if I had drawn a circle, that looks more like an ellipse. You still could have 4 intersection points there, as you can see. That is a possibility. I don't believe that that's what's going to happen on this one, but that is a possibility. All right, so a couple of things. In order to use the elimination method here for addition, what I should see is I can't add the y and the y squared together. Those will not combine to get rid of each other. However, the x squareds will. This one and this one, I can add those things together if I make one of them negative, and it'll go away. The problem is they're not lined up correctly, and that is something that we do need to do. So we're going to rewrite this. I'm going to keep the bottom one exactly like it is. X squared plus y squared equals 9. I want to subtract that x squared to the left-hand side. When I do that, it's already going to be in the proper form because it'll be a negative. So if I subtract the x squared, I'm going to line it up over top of my x squared. I can't put the y over top the y squared because they don't match up. They're not the same term. One is squared, one is not. So I have to put the y kind of out here in the front. And then I'm going to keep the equal sign lined up, so it's 3. So all I did was subtracted the x squared to the left, but I'm making sure I line up like terms. That's the big thing there. Make sure you line up your like terms. So now when we add these things, well, I'm going to add straight down, and the y has nothing to be added to, so it just comes down. The negative x squared and the x squared, those go away. That's perfect. I do need to bring down the y squared, and then I have to add the 3 and the 9, which is going to give us 12. So once again, what I have here is I have a quadratic, which means I'm going to subtract the 12 to both sides so I can get one side set equal to 0. I am going to rearrange the order of the bottom here. I'm going to write it as y squared plus y. And then we'll subtract 12 on both sides and make sure that that's equal to 0. So now we can go ahead and factor this thing. So if we factor, we're going to get a y there. The factors of negative 12 that are going to add up to positive 1 on the middle there is going to be positive 4 and negative 3. So let's go ahead and solve that. So y equals negative 4 or y equals negative 3. So we have two different values that we have to test. And let's go ahead and see if this gives us some good values here. So I'm going to go ahead and I think the top equation probably looks like it's the easiest one to use. So I'm going to plug the negative 4 and the positive 3 into the top equation. So these are y values. So we're going to get negative 4. Here, this is when y equals negative 4. So negative 4 equals x squared plus 3. So to solve that, we got to subtract 3 on both sides. So subtracting 3 from negative 4 is going to be negative 7 equals x squared. Well, here's a problem. This is going to be a big problem. When I try to take the square root of this thing, I'm going to end up trying to take the square root of a negative value. That does not exist in the real numbers. So what that tells me is, when I try to take the square root of both sides of this thing, I'm going to get no solution. You cannot take the square root of negative 7 in the real number system. They would be imaginary solutions. So we are not really going to be dealing with that. So this is extraneous. There's no solution to this part right here. I still have to check the other value. That was when y equals positive 3. And again, I'm going to plug that into my top equation. So I'll plug 3 in for y. X squared plus 3. Subtract 3 on both sides, and you get the 0 equals x squared. The square root of 0 is something we can do. It's not negative, so it's possible. If I take the square root of both sides here, I get that x equals, it's technically the positive or negative, but it's just 0. There is no such thing as a negative 0 or a positive 0. 0 has no value, has no sign. So it's just 0. So really what that tells me is there is one solution to this thing, and it's at the point 0, 3. One solution, which means that parabola intersected that circle at one point, meaning it just touched the circle at one specific place. Okay, so that's enough examples for this section. You should have enough to be able to do the homework.